Welcome to Building Thinking Classrooms in Science. My name is Michelle Brasso. I teach physics, earth and space science, and general science to students in grades 9 through 12. In this session, I want to offer you practical ways to get your students out of their seats, collaborating and thinking in your classroom. The first two strategies from this session come from the research from this book, Building Thinking Classrooms in Mathematics by Peter Liljedahl. Now, I know what you're thinking. It says mathematics here. Trust me on this one, these two strategies would be applicable in any classroom and really get your students thinking. In addition to this session, there is a bonus video on assessment and free resources for you to use in your classroom based off of the activities that I'm using in this session. If we want a more active thinking classroom, we need students to take more authority for their learning. One way to do this is to use group work. Now, generally, group work is sort of wishful thinking, that we need to build in some structure and teach students how to work with one another. And in particular, we want students to be able to work with anyone in the classroom, to collaborate with anyone in this room. In order to do this, we implement visibly random groups. Not homogeneous, not heterogeneous, completely random, but we also show students that we don't know the groups in advance. The reasoning behind this is that we want every student to be able to work with anyone in the classroom. We want to build those collaboration skills, we want to build those interpersonal skills, and we want them to learn with one another and from one another. In my classroom, I really want to build this community of inclusion, that we can all work together. The best group sizing that I've found is 3. I find in groups of 4 that there tends to be some redundancy, and students might basically be better off being split into 2 groups of 2, if that was the case. Optimal 3, otherwise use smaller groups of 2. The way that I form the groups is very random and it's very obvious for students. I have these decks of cards and you can get these online. They are blank on one side or you can get some that are blank on both sides. And at the start of the semester, I take a Sharpie and I write the students' names on them. And then almost daily, I'm putting them into visibly random groups. And they know that it's very random. They know that I have no tricks up my sleeves because as I'm explaining the activity, I'm actually shuffling the cards. So this just becomes part of our classroom culture. I'll explain the activity while I'm shuffling the cards. They know I'm not tricking them. They know I am not keeping them away from their friends. Sometimes they will be with their friends, sometimes they won't, but they'll be willing to work with everyone. It really improves the classroom culture. So once the cards are shuffled, I deal out groups of 3, and then I really hype it up. So once I flip them over, I'll say, oh my gosh, student A, you get to work with student B and student C? Nice! And do that for every group. Student D, you get to work with E and F. Woo. Student G, you're working with H and I. And I often do this underneath the document camera so they can see this in real time and really truly know I'm not pulling any strings here. Ultimately, I want them to learn from one another. I want them to build their interpersonal skills, their collaboration skills, and I want this to be an inclusive classroom where everyone can work together. Are your students hiding from the responsibility of their own learning? When they're at their seats, do they look like they're writing, but really they're just doodling? What if they strategically place a backpack to reveal a cell phone? Or what if they say they're on their calculator, but really they're just texting? Those behaviors have no place in a thinking classroom. We want students engaged with the lesson and not distracted by other things. So how can we remove those distractions? Well, first, let's clear the table of all the things. and all the students too. We're going to get students up and away from their desks. When they're up and standing, they are less likely to become distracted, and they'll have more oxygen and glucose to their brain too, so that will get their energy up as well. Then let's bring students in visibly random groups to vertical non-permanent surfaces. These are things like whiteboards, mobile whiteboards, whitebooks, areas where students can brainstorm and think together. I love using these mobile whiteboards in my classroom. I don't have a lot of space. I've got a lot of cupboards, so I don't have a lot of space where students can actually work vertically. So I will move these around the classroom. From there, I give students an interesting problem. The best problems are the problems that make students think rather than mimic. So one of my favorites from earlier this year was design a roller coaster that has a maximum speed of 100 kilometers per hour and includes a loop for which the rider feels weightless at the top. This one worked wonders because it connected some ideas that students hadn't previously connected, but all students had an entry point for this problem. It was a sort of low floor, high ceiling. Low floor because any student could get started, and high ceiling because any student could get stuck. This problem caused a student at the end to say, "That problem made me think I was dumb." And I told them to backspace those last 3 words. Get rid of the "I was dumb." That problem made you think. And you may not be used to that in high school. You might be used to mimicking, but in this classroom, you're a thinker. So in using these vertical non-permanent surfaces, we would want students in visibly random groups and give them an interesting problem. If you can, give them the problem orally. Just speak it aloud, be ready to repeat it, and maybe write down a few key values. Another way that you can do this is by posting the problem on the work surface that the students will be working at. That works too. As the students are working and thinking, you can be circulating around, seeing who is really being a great leader, who is contributing, and you can collect that data. You can also see who's kind of sitting back, which shouldn't be too many people if you're using small enough groups and you're fostering this communication between them. You can give them some encouragement. You can also point out things that look really great, draw a box around that, and then when you're consolidating these problems at the end of this session, you'll see I've got this box around something on a whiteboard. I want to talk about that. So this is a great way to get your students up, active, thinking, and taking responsibility for their own learning. The other great part here is that since they're working with one another, they are accountable to one another as well. This will build inclusion, this will build thinking in your science classroom. If you have had enough of lecturing and you want your students to take a more active role in understanding calculations, might I suggest having them annotate answer keys. This is really useful in courses that have calculations that are multiple steps. I'm thinking physics, I'm thinking stoichiometry and chemistry, and this is for the type of student that they have no problem with the actual computation part, but we don't want them mimicking. Instead, we want them understanding why they're doing this calculation. So in order to set this up, you'll need answer keys that are printed. I like to print mine in color so that the students can annotate in the same color that I've written the answer key in, and some chart paper or larger paper. So I like to glue the paper down for the students and then invite them, after making random groups, visibly random groups, to kind of get on each other's cases. So imagine that you're the first student up, you need to explain the first step. The other students will be saying, why? Why do we do that step? Why is it like that? Why is it that equation? Keep asking that question, why, like a really curious toddler, and getting all of the information on why we do these calculations in this way. From there, they'll switch out, they'll take turns annotating the solution. It's really effective for students to understand the reasoning and not just mimicking the same calculation over and over. Now, a nice spin on this is if there are multiple ways to solve a problem. So I take then the problem and I give them the alternate solution, and I have them glue it down on the opposite side of the chart paper. And in that way, they're able to compare and contrast multiple solutions, and they're able to choose which method works best for them. That's going to be higher level thinking than just copying from the screen or from the board. And this way they get to think about what the steps are, why we do those steps, and start to internalize this. Whether you call them exit tickets, entrance tickets, bell ringers, do nows, I love these for collecting quick data on our students. So with these bell ringers, I like to start them at the start of class. If timing allows, I actually like to have them set out on the students' desks. And these are just quick questions that give me an instant piece of data on our students and how they're doing. In terms of creating them, it's not too bad. You can choose a question from yesterday's class or from a few classes ago, or even spiral back to a few units ago just to see how well students are retaining that information. From there, I have students drop them off in a central bin at the front of my classroom. That's the go-to for all things being submitted, and then I'll collect them. To be honest, it would be nice if I could look at them during class, but I'm often too busy teaching that I often get to them after class instead. But they are very quick for assessment. When I'm assessing them, it's actually really quick to do. I generally use 3 groups for sorting the bell ringers, and this makes the process go by very quickly. The first group will be students that got it. They're good, they've got a nice understanding, and they've shown the evidence of their understanding. That's the first pile. The second pile is for students who are almost there. Maybe they made a silly mistake, or they need more support in their answer, or maybe they need a stronger support in their answer. That goes to the middle pile. And then there are the students that just didn't get it, and that forms 3 piles. So I'll go through and sort them into all of those piles as I'm reading. I'm not recording yet. So now that I've got my 3 piles sorted, I've used 2 different methods that have worked really well for recording this information. At first, I would use 3 colors of highlighters: green, yellow, and pink, because, well, some people don't like red, and that's fine. So what I would do is on each of the bell ringers, I would just highlight it with green, meaning good to go, or yellow, meaning we have to address a little thing, or the pink saying we need to stop and we need to get some clarification on this concept. That has worked really well for me, and I've also just recorded it that way on my roster, where all of the students that have green would just get recorded as green, and that's a nice visual way to see it. It works quite well. My new way of recording things has to do with the data assessment framework, and it's more of a standards-based grading. If students were in the good to go pile, they would get a check mark, and that would just get placed on my roster as well. So all of these can very quickly give each student a check mark, and I can also record all of those check marks really quickly on my roster. Those are the students I don't need to follow up with. But I have my students that had some sort of silly mistake, or they needed more support or stronger support. For those students, I give them an S. They know what that means. Silly mistake, needs more support, or stronger support. And then I'll record those on my roster as well. And then I will give those back to the students and check in with them during class. And then I have my students that didn't get it. So with this, it's an X, and that's a follow-up conversation with me as well. So that gets recorded in my roster. And then I'll look for the curriculum expectation code that aligns with what this bell ringer is showing, and I can record that data also on the student page. And that way it gives me this holistic view of how the student is doing, which is really, really nice. I can see that they're excelling in some areas and maybe not so much in others, and then we can very accurately pinpoint what interventions are needed to help the students in their weaker areas so they can experience success. One of the quickest and easiest ways you can get students up working with one another on a curriculum-related task is with Tarzia puzzles. I absolutely love these and have been using these for over a decade in my classroom. There are basically two flavors of these puzzles. There are the domino puzzles, which are kind of like I have, who has, but everybody gets the questions and they can be working on these individually or as a small group. And these sort of matching puzzles that create a cool shape, like this one here. To implement this with students, I would form visibly random groups. So, as before, I would be walking around shuffling the deck of students' names so that they know that it's completely random who they're working with, and they very quickly accept that. And I'll deal them out. And then from there, the groups are formed. I'll give them their puzzle. Eventually, we get to the point where I just drop these on students' desks before the students even come in, and they know right away to get started on this puzzle. With the domino puzzles, what I really like about them is that it gives them continuous practice on the terminology in their course. If you consider something like a word search really doesn't teach the student anything about the meaning of the word. So personally, I find it useless in a high school classroom. Similarly, crossword puzzles can be solved just by using the length of the word. It doesn't give them that much more than a word search, and students tend to only do the crossword puzzle once. Whereas with domino puzzles, you can continually use them throughout the unit. I actually love to use them on the first day of the unit, and then students get a bit of a preview of what they're going to learn, and I get a bit of a preview of what the students already know. Students can reuse these puzzles weekly. They can take a copy home to study for their test or their final exam. And basically, how these work is there's a start piece and there is a finish piece. In between, students are matching terms to definitions. So a device that controls the flow of electron by opening or closing a circuit. Students are looking for the word switch. Aha, there it is. So they'll match those two up. And then with that term, they're given a new clue, the controlled flow of electrons through a conductor, which is current electricity. There it is. So they're doing some thinking. They've got much more active minds. They can work with one another, and these activities are repeatable. These activities can also be used to practice mathematical skills. So you can do some sort of calculation. In this case, this puzzle is doing metric conversions, and students need to match up the appropriate sides. When they do that, they have a match, and other students can be looking for other matches. They can be talking with one another. They can be having a little bit of maybe a dispute of what matches and work that out and learn through the process. Personally, I love using these in the first week of class so that students can get practice with one another, working with one another, and this is more exciting than a worksheet. A way that you can get students working together on their critical thinking skills and provide an opportunity to assess individual work and add a little nice decoration to your classroom is by creating a timeline. In this activity, I broke students into visibly random groups of 3, and I assigned each group a decade. That group had to research the astronomical discoveries from that decade and rank the top 3. From there, each student chose one of the 3 discoveries from that decade and wrote a little summary on it. That added to our timeline in our classroom, and I was able to assess student work, build their critical thinking skills, and add a little decoration to our classroom. If you're looking for a research activity that reduces plagiarism and is pretty quick and easy to assess, might I interest you in this March Madness assignment? This is one I've been doing for years, and it's super effective. Why? Because this one does not focus on a technology and who discovered it or who invented it and how does it work. It's not really Googleable. So in this assignment, students choose a technology related to one of the units that we've studied in the course. From there, they need to research and report back on why this technology is the most influential technology of all time. In doing so, they'll learn all of those factual things: who invented it, where was it developed, what year was it invented, all of those Googleable things. But this assignment is asking us to look into, why is this technology important? So students choose their topic, and once they've written it, they'll submit it to me, and then I assess it right away. I personally don't want their performance on the bracket to influence how well they do on the assignment, so I assess it before a debate. I set up the brackets randomly. I do try to avoid having very similar technologies go up against one another if I can avoid it. So it's mostly random in this case. And from there, students will debate. So we'll have 2 technologies up against one another. Each student will share their report, and then if students want to, they can go through some debate tactics like the rebuttals. That's personally not my thing. I'm not well versed. I'm not really a debater, so I give that as an option for the students, but they don't have to. Some students get really into this, and once we have both of the arguments presented, students do an anonymous vote to determine which technology moves forward. Not which student moves forward, but which technology moves forward, because it's all about the technology. This is not a popularity contest. So from there, we narrow down which technology our class votes to be the most influential of all time. What I love about this assignment is that it shows why these technologies are important and the influence they've had on our lives, as opposed to just facts that are easily Googleable. So this is a very rich project that involves some critical thinking, and you will be very impressed by how far your students can take this one. Some variations that you can do are which chemical or which molecule is the most influential of all time, which biotechnology has taught us the most, or something that I've done is which astronomer is the most influential of all time. The hexagon is the bestagon, and that's why I love hexagonal thinking tasks. Well, that and the reason because it is also another activity where students can get up, they can be in visibly random groups, and working on thinking critically about the unit that they're studying. It's pretty simple to put together. On these hexagons are terms that are relevant to the unit. Here I have terms that are related to astronomy. So towards the end of the unit, I would offer these up to students, putting them into visibly random groups, and ask them to find the connections. Now this is different than a Tarzia puzzle, because in a Tarzia puzzle, there's a correct answer. With this, there's no one right correct answer. Instead, we're looking at how students are thinking critically about all of these different terms and concepts in the unit. So as students get started, they'll likely want to separate all of these terms, and then they may want to start sorting them. The way that they sort them is completely up to them. So they might sort them based off of composition, classification, location. That's all perfectly fine. We want students to find different connections and to have a great conversation about what they're connecting. Once they have some connections, they can start trying to match everything up in terms of what will go together. We don't want anything all by itself here. So as they go through, they can start connecting these different concepts. Students can make different groups that are connected in different ways. Keep this very fluid by not gluing it down until students are ready to annotate. When they are, you can have students glue the sections down and write down what are the connections here. So maybe there's a common theme to this group, like maybe this is about rocky objects, and finding those connections. What's the connection between a crater and a meteorite? What's the connection between craters and volcanoes? Or, for example, down here, what's the connection between Jupiter, Saturn, and the Sun and stars? So they're all composed of hydrogen and helium, so that's their connection. Maybe the Sun is part of the Milky Way, and the Milky Way is related to Andromeda because they're both galaxies. So let's try annotating some of this. So students get the opportunity to show the depth of their thinking, and this would make a phenomenal test or exam review. If you are finding that students are struggling getting into this activity, you might offer them a few ways to get started, maybe by finding some objects that group together by composition. And if you want to make this a little bit more challenging, you can offer students blank pieces, blank hexagons, where they have to write in something new that's not already included. And maybe that's a connection between some already existing groups, or you can have completely new connections. Just get those students thinking, get them working with one another, and get them in charge of their own learning. Thank you so much for attending this session. In addition to the tips you learned here, there are free resources in the drive that you can implement right away and a bonus video on assessment. I would love to connect with you. I'm at Mrs. Brasso's Binder on Instagram and TPT, or you can email me at mrs.brasso@gmail.com.